Hi everyone. Today we're going to look at finding areas of similar figures using scale factors. You've already learned how to find the areas of basically any figure that you're given. Now we're going to look at how does this relate to similar shapes. So what you need to know is that if two figures are similar, then the areas are proportional to the square of the scale factor. So for example, if we're looking at these two shapes, the blue shape and the green shape, if you look at the perimeters, we already know that the perimeters are equal to the scale factor. But if we look at the proportion of the areas, it's always equal to the scale factor squared. Let's use this in a problem. It says triangle JKL is similar to triangle PQR, and the area of triangle JKL is 30 inches squared. Find the area of triangle PQR. So what we have to do here is first find the scale factor. So the scale factor, we're going to look for two sides that we know are corresponding. JK corresponds to PQ. So I know that I have the measures for each of those, so I can put 12 over 15. Now since I did the blue shape in the numerator and the green shape in the denominator, I have to keep it consistent when I'm putting the areas in. So for the areas, I need the blue area in the numerator and the green area in the denominator. I don't know the area of the green shape, that's what I'm trying to find, so I'll just put in X. Now this works for perimeter, but for area we have to square the scale factor. You can reduce the scale factor first if you wanted to also. Those are both divisible by 3, so you would get 4 over 5 as the scale factor if you wanted to do that first. In this case, it's going to be a little easier to square these if we reduce it first. 4 squared is 16, 5 squared is 25. When you're squaring a fraction, you have to square the numerator and square the denominator. Remember, to solve this, you cross multiply and divide, so you have 30 times 25 divided by 16. To solve it, you multiply the 30 by 25. That gives you 750, and then you divide by 16, which gives you 46.875. What that means is that the area of triangle PQR is 46.875 inches squared. Try the two practice problems below. Here are the correct answers. This time it's going to be a little bit switched around, so I'm going to give you the areas and you either have to find the scale factor or a missing measure. So it says the area of parallelogram ABCD is 150 meters squared. The area of parallelogram FGHJ is 54 meters squared. The parallelogram of ABCD is similar to parallelogram FGHJ. Find the scale factor and the value of X. So what we know is that the scale factor squared is equal to the ratio of the areas. So what we can do is to find the scale factor, JH corresponds to DC, since they're in the same spots on the similarity. So what we can do is put X over 10 to find the scale factor. Now remember, we have to square that in order to find the scale factor squared. X is coming from the blue shape, 10 comes from the green shape. So we have to stay consistent when we put in the areas. The blue shape goes in the numerator, the green shape goes in the denominator. Now there's two methods to solve this. Alright, so the first method is that we can square the numerator and the denominator of the fraction first and then solve. So you can reduce this 54 over 150 if you'd like. It's not really totally necessary for this method, but what we need to do is cross multiply and divide. So when we cross multiply 100 times 54, that gets us 5400 divided by 150 gives us 36. So we're looking for what number squared gives us 36. We can find that by square rooting both sides. Remember, when we square root, we need positive or negative. However, x represents the side of a parallelogram in this case, so we're only dealing with the positive form of the number. So we only want positive 6 as our answer. So I got x equals 6. Now I have to go back and find the scale factor k. To find the scale factor k, I already have the fraction here, x over 10. All I have to do is plug in the value for x. So 6 over 10, that can actually reduce to 3 over 5. So you should reduce your scale factor if it's possible. Now the other way that we could do this is get rid of the squared first. So if you wanted to get rid of this squared, we could square root both sides. So you would have x over 10 equals the square root of 54 over 100. Again, normally you would do positive or negative when you square root both sides, but it's not really necessary because we know x has to be positive. So to solve this, the first thing I would suggest is reducing this fraction, 54 over 100. 54 over 100, that can reduce, this should be 150, 54 over 150, that can reduce to 9 over 25. Now this makes it a little easier to do the square root because I know with a fraction I can split it up. Square root of the numerator over square root of the denominator. Square root of 9 is 3, square root of 25 is 5. Now this looks like a problem that I'm used to solving. Cross multiply 10 times 3 divided by 5, that's 30 divided by 5, or 6. Notice either method you choose, you'll get the same answer. Once you have 6 as x, it's the same. From there, we plug it back into k for the scale factor to get 3 over 5. So either way you do it, you'll get the same answers. Try the practice problem below. You can use either method you want. Here are the correct answers. For the first one, I chose to use method 1. The second one, I chose to use method 2. It doesn't matter how you do it, as long as you get the correct answers. Let's do another one together. This says we're using scale models. It says Orlando and Mia are making a scale model of the Pentagon. The Pentagon is approximately 1,481,000 square feet of land. Each outer wall of the regular pentagonal building is 921 feet in length. If the area of the base of their model is approximately 50 square inches, about how many times the length of each outer wall of the Pentagon is the length of the outer wall of the model? We did problems like this when we were talking about scale factors previously, but remember, you need to read that last sentence and write it out word for word. So how many times, that's x, the length of the actual Pentagon is, remember, is represents equals the length of the model. Now we're not talking about areas here, this is talking about lengths. So I know so far, I know that the actual length of the outer walls is 921 feet. I do not know the length of her model, however. So I'm going to have to find this first based on the information they gave me about area. So I know that if I could find the scale factor, which is going to be, so let's look at the scale factor first. So I'm looking at the actual building, which is 921 feet, over the model. This is what I don't know. Let's use a different variable because I already used x, so let's use a for the actual. Oh, sorry, we're finding the model. Geesh. M for model. So what I'm doing is I'm putting the actual building in the numerator, the model in the denominator. That will help me find the scale factor. I have to square it if I'm going to compare it to the areas. Now I know the area of the actual building is 1,481,000 square feet. The model is 50 square inches. So this is in feet, this is in feet squared. The model is in inches squared. So it's okay, my model is going to end up in inches, so that's fine. I just have to make sure I'm consistent once I get to my equation. So let's see if we can solve this. You could solve it using method 1 or method 2. It's up to you. But you might want to reduce the fraction first. So 1,481,000 divided by 50, that's 29,620 over 1. So we can reduce that fraction first. Now what I can do is I can square root both sides. So I'm going to choose the second method of square rooting both sides first. So I get 921 over m equals the square root of 29,620 over 1. The square root of 1 is just 1. So now I cross multiply and divide. I have 1 times 920 divided by the square root. So that's just 921 divided by that square root. That gives me about 5.35. Remember, we said the model is going to have a length in inches since the area of the model was in inches squared. So now the model has a length of 5.35 inches. Now, I can't solve this equation because it has two different units in it, and I'm solving for x. So I can't divide inches by feet. It would give me inches over feet, but I don't want that. I just want the units to cancel out. So in order to make that happen, I'm going to have to either change the feet into inches or the inches into feet. I'm going to choose to change the feet into inches. I can do that by multiplying by 12. So I know this is the same as 11,052 inches. Now I can go ahead and solve it, and my units will cancel out. So I have 5.35 divided by 11,052. That gives me a very small number. If you're typing that into your calculator is going to pop up with this, 4.84 with a bunch more decimals, e-4. On your calculator, this means scientific notation. So it's kind of like times 10 to the negative 4. So another way to write this is 0.000484. Notice the decimal place is moved over 4 places. So what this means is that the length of the outer wall of the pentagon is 0.000484 times the actual pentagon is how long the model is. We could also write this as a fraction if you wanted, if it's possible. In this case, it's a little difficult to change to a fraction since it's such a tiny number. Alright, I want you to try the practice problem below. I know this one's a little bit challenging, these scale model problems, but go ahead and give it a shot, see if you can do it. Here's the correct answer. See if you got it right. Now the reflection question for today. I want you to try to see if you can draw a pair of similar figures with areas that have a ratio of 4 to 1. Explain how you know that you are correct in 1 to 2 complete sentences. That's all for today. The most important parts of this were examples 1 and 2. Remember, example 3 was a challenge problem. So as long as you are understanding 1 and 2, that's very good. We can work more on example 3 together. And that wraps up the chapter. So you've learned everything there is to know from our book, at least, about area and perimeter of different polygons, along with the areas and perimeters of similar figures. So hopefully you've become a lot more aware and knowledgeable on areas and perimeters. That's all I have for you today. I'll come back in a few days with the next chapter, which will be circles. See you then. Bye.